example says, find parametric and symmetric equation. Find parametric and symmetric equations of the line passes through these 2 points. First point, you have 2, 4, -3. And the second point, B, 3, -1 and 1. Okay, perfect. Parametric equation, the symmetric equation. Okay, perfect. So what do we have here? We have 2 points on our line, and then we don't have any known vector v, which the line is parallel to that line. Again, we call that the right equation of a line in the space. We started by having a point on the line, so it was x-axis, it was y-axis, and it was z-axis. And we had this line L, and then we say, hey, we must have this known vector v, a, b, c. The line is parallel to that vector, and we take 1 point, p sub 0 on the line. We construct the vector connecting the origin to p sub 0, we call it r sub 0, this is our vector. Then we take the second point, like p, with coordinates x, y, z. Then we construct the vector connecting the origin to p, we call it r. And then we say that, hey, we have another vector here, which is vector a. Our vector a is parallel to vector v. And then the sum of the vectors actually help us to write this relation between these vectors. It was r equals to r sub 0 plus a. And since a and v are parallel to each other, we can use a parameter like t. We can write it as t times. So what do we have here? We have 2 points on the line. Since we have 2 points on our line, and we don't have vector v, a, b, c. Since you have 2 points on your line, you can actually construct that direction vector. We can construct the direction vector. This direction vector is a vector connecting these 2 points. Vector v is AB times a value, times a number. So there is a connection between v and, so multiplied by something, let's write it here. So this vector v is equal to AB times something. So there is a connection between them. So let us construct AB. AB, this is vector 3 minus 2, 3 minus 2. Look at the symbol that I'm using, 3 minus 2, then -1 minus 4, then 1 plus 3. AB is equal to 1 minus 5, and we can use this vector and write equation of the line. Perfect. So what is your r sub 0? Which point you should select? which point you should use. It doesn't matter. Let us use point A and construct vector r sub 0. So your vector r, which is the sum of r sub 0 connecting the origin to point A, it's going to be 2, 4, -3 plus t. T is a parameter, a variable, so you have to copy it down. And vector v. You know that this vector AB is parallel to vector v, so this is parallel to. So we can use that, why not? T times 1 minus 5 and 4. You can leave it as it is, or you can write it in nice compact form. X, Y, Z. This is vector R. The position vector is equal to 2 plus T, 4 minus 5T, and -3 plus 4T. This is vector equation of your line. Question says, find parametric and symmetric equations. When you have vector equation, the rest is simple algebra. There you go. Now that we have the vector equation, the rest are easy. To write the parametric equation, x, the first component, is equal to the first component. X is equal to 2 plus t. The second component is equal to the second component. Y is equal to 4 minus 5t. The third component is equal to the third component. You have equality between two vectors. So z is equal to -3 plus 4t. Well, this is the parametric equation. Parametric equation of this line. Now we can write the symmetric equation of the line by setting t equal to all of those fractions, so the fractions must be the same. Here you have x minus 2 divided by 1 equals to t, y minus 4 divided by minus 5 equals to t, and finally z plus 3 divided by 4 equals to t. So it means that the symmetric equation is x minus 2 equals to y minus 4 divided by -5 equals to z plus 3 divided by 4. This is the symmetric equation of your line. So we started by writing the vector equation, we got to parametric equation, and now we got to symmetric equation.